Now let's understand the remaining concepts from tree unit. Those are spanning tree, minimum spanning tree, in which we shall study two algorithms. Those are Prim's and Kruskals algorithm. Last point, we shall study Huffman coding, which we have as a practical implementation. We are going to implement that Huffman coding part in C++ language as a practical assignment. Let's first understand what is spanning tree. Given a connected undirected graph, which comprises of number of vertices v and number of edges e, and we need to form a tree which consists of v dash vertices and e dash edges. That is called as spanning tree. If it holds the, if it acts as a subgraph of G, that is v dash is a subset of v and e dash is a subset of e. Basically, it spans the graph. The original graph gets spanned, and v dash is equals to v, and it doesn't form any cycle, any circuit. That's why it actually acts as a tree. That's the naming convention given, spanning tree. And e dash, the number of edges the spanning tree has are nothing but v minus 1 edges. And spanning tree, the definition of spanning tree: a subgraph T of an undirected graph is a spanning tree of G if it is a tree and contains every vertex of G. Note that spanning tree must contains every vertex of G. Now consider this example where 6 vertices are present, and total there are 10 edges are present. So we can form a spanning tree, and spanning tree out of this particular graph. First spanning tree we have formed here, which consists all the vertices, 6 vertices, but the edges have been reduced, 5 edges. We can form any number of spanning trees of a given graph. So this particular graph can be formed with the other technique, and the formation of the spanning tree look like this, and third formation look like this. So we can conclude that any number of spanning trees can be formed out of the graph. Now suppose, next bit is, suppose weights are provided to every edge in the original graph, okay, and we have to conduct such a construct such a spanning tree which consists of minimum weight edges. Such a type of spanning tree basically called as minimum spanning tree. Here given a graph with weighted edges, and we need to construct such a spanning tree which consists of minimum weight edges only. So that kind of spanning tree is called as minimum spanning tree. The definition says that edges are weighted, and find the minimum weight spanning tree, out of which the applications are very vast of minimum spanning tree. Find the cheapest way to wire our house, find minimum cost to send the messages on the internet, etc. The strategies for forming the minimum spanning tree can be is kind of pseudocode or algorithm. For any spanning tree T, inserting an edge, the new edge, not in the T, creates a cycle, but removing the old edge from the cycle gives back the spanning tree. If the new edge has a lower cost than the old edge, we have progressed. Then we have got the minimum spanning tree, final minimum spanning tree. Now, strategy for constructing the MST is add an edge of minimum cost that does not create a cycle. It's basically a greedy algorithm. Greedy means picking up the minimum weight edges, minimum cost edges. And repeat this particular step with for v minus 1 times. Two algorithms have been introduced to construct the MST. First is Prim's algorithm, and second is Kruskal algorithm. We shall see the Kruskal algorithm later. First see the Prim's algorithm. Pick the minimum weight edge connected to the known spanning tree that does not create a cycle and expand to include it in the tree. In other words, we can say that the Prim's algorithm is basically a greedy algorithm. Means while constructing the minimum spanning tree, we go on choosing the minimum cost edge, starting from the first vertex till the last vertex of the graph. The idea here is to maintain two sets of vertices. The first set contains the vertices which are already included in the MST, and other set contains the vertices which are not yet included in the MST. At every step, it considers all the edges that connect the two sets and picks the minimum weight edge from these edges. After picking the edge, it moves the other endpoint of the edge and to the and it shall include in the final minimum spanning tree. Let's take one example to simplify the concept. Here is the graph which has 7 vertices and 11 weighted edges. Here the weights have been allocated to the edge. Now starting from the empty T, now we have the empty spanning tree. Initially we have choose the starting T spanning tree as T notation. Choose the random vertex. We shall pick the vertex A. Now consider the edges from A to other vertices. There are three edges which shall lead us from A to B, A to C, A to D. Now A to C, this edge has the minimum weight, that is 1. So we shall pick this edge AC. Now consider the edges from vertex C. Okay, now consider the edges from vertex C to other vertices. Okay, C has landed to D, and weight is 3. C has landed to F, has the edge weight 6. C is traversing to B with edge weight 8. Here out of these three edges, 3 is the minimum cost edge, so we shall pick this edge CD. Okay, like this. After picking this edge and after picking CD edge, our array will look like this. Edge array will look like AC, CD. Later on we must check the outgoing edges from this D vertex as it is visited, and 5, 4 out of this we shall pick the edges one by one. While comparing the edges 4 and 5, 4 is minimum, so we shall pick the edge DE and we shall go on picking the edges which has minimum weight. You can see here. After that we have picked EGH. We have repeated this process till we reach the last vertex in the graph, and we have got the final vertices set as all the vertices, and edge set has got the 3 edges which has the minimum weight, and final cost of this tree is 16. Starting from the starting vertex A to reach to the ending vertex G, we have utilized the cost 16 through Prim's algorithm. Hope you understood this algorithm. Hope you understood the concept. Next, move on to the next algorithm, that is Kruskals algorithm. Basically, it builds the MST on sorted edges, where we pick the minimum weight edge, which is not yet present in the MST. That does not create a cycle. Then expand the set of included edges to included. In other words, we can say that Kruskals algorithm, basically a greedy algorithm. It makes a greedy choice to pick the minimum weight edge that does not cause a cycle. It's as simple as that. The next picked up edge must not create the cycle in the MST constructed so far. So we can have the 3 steps to build the Kruskals algorithm. First step is sort all the edges in non-decreasing order of their weight. First of all, we need to sort all the edges. Second step is to pick the smallest edge. Check if it forms a cycle with the spanning tree formed so far. If cycle is not formed, include this edge, else discard that edge. Third step, repeat the step number 2 until there are v minus 1 edges in the spanning tree. Okay, hope you understood the 3 steps in this algorithm. We shall see the example, how these steps we can apply to solve this example. Consider the undirected weighted graph here, which has a total number of 8 vertices and 14 edges. Now sort the edges by increasing edge weight. Starting from the weight edge 1, we have got the first edge DE, and ending to the highest weight edge, that is 10, we have got the last edge is AF. Total 14 edges have been sorted here with the ascending order and edge weight. Select the first vertex, that first edge, that is DE, which has the minimum edge, keeping in mind that it do not generate a cycle. Next, move on to the next edge, which has the second minimum edge, that is DG, keeping in mind that it do not create a cycle. Yes, it do not create the cycle, so we have picked up that edge. Next, move on to pick the third edge, that is EG. EG creates a cycle. That's why we do not accept that edge which forms the cycle, so it is not accepted. Next, move on to picking up the next edge, that is CD. CD do not form the edge, so it has been picked up. Next, we have move on to the edge GH, which has the weight 3. Pick up. CF, it do not form the cycle, then pick up. BC do not form the cycle, so we have picked it up. BE forms a cycle. BE forms a cycle from this for these 4 vertices we can see here. So BE is not picked up. BF forms a cycle, so we have skipped that edge. BH forms a cycle. AH, on the other hand, do not form a cycle, so pick up that edge. DF, AB, AF is not considered because we have got our minimum spanning tree as soon as we reach to this edge AH.